So we discussed in the last part of chapter 6, we discussed some healthcare application, we discussed some cloud-based applications and some autonomous system. Today we're going to talk about some other emerging technologies. One of the technology or one of the emerging technologies, social media, which is playing a very important role in our lives, especially in politics as well. So in politics, by using social media platform, most of the candidates, they do have their Twitter accounts, their Facebook pages to run their campaigns. It's called digital campaigns. The best thing is in social media, people can use social media for their quick message delivery. So candidates can quickly deliver the message, share their thoughts for any ongoing events, stuff like that. And social media was really emerged, especially in politics. It was really emerged back in 2016. So some people, they believe one of the biggest winners of 2016 presidential election was social media, because it played a very important role for awareness, and people are the candidates, they have highlighted their contributions and stuff like that through that social media. Other than that, another very important tool which is becoming very common in the political campaigns, it's called data mining. In data mining, what exactly happens? It collects the data. Let's say this is the large amount of data. So by using some data mining tool, what can happen? It can filter the data. It can find some useful. Let's say this is the bunch of data of all online search for a specific area. So by using a data mining tool, for example, a political data mining tool, it will collect the political information, like it will filter out the useful information, like useful information regarding, for example, political biasness or stuff like that. And then this particular information can reveal very significant data, significant information about what people think about a specific candidate and stuff like that. So data mining is becoming very common nowadays in political campaign, and political candidates, they extensively use data mining. So the thing is that data mining is, firstly, let me define data mining. Data mining collects the online data and then sketch, specifically for political data mining, in fact, sketch the personality of individuals, like what kind of person they are, which party they like and all that stuff, which candidate they actually like, and what kind of things attract to them. So because of that, it can reveal significant information. It can reveal significant information that can impact elections, which is why it became important tool for political candidates. So there are many data mining tools, and political candidates, they use those particular data mining tools to see which particular areas they need to focus, which particular things people are asking for, and stuff like that. The next is asymmetric warfare. Asymmetric warfare is very common nowadays. What exactly it is? Like for example, if where the military strength of two fighting countries, fighting forces or countries differ significantly, then cyber attacks can level the battlefield. and how they can actually level the battlefield by targeting their utilities websites, and just to launch some economical disaster, just to actually bring economical instability in that region. One of the most widely or the recent asymmetric warfare attack, it is called ransomware. Sorry, the name is WannaCry ransomware attack, which targeted British banks, and it was launched back in 2017, just 3 years before. The next is the technology which will replace over all computational thinking, and the way how we manage our computers and all that stuff will get changed with the introduction of quantum computers. So quantum computers, they don't use digital data like 0101. They use a specific kind of bit which is called qubit. So qubit is similar to 01, but it uses atoms and molecules. Like in 01 we just have two states, like either it will be fully on or it could be fully off, but in qubits there are infinite states in between. So a few things in quantum computer, they use the power of atoms and molecules for processing and storage. Secondly, a qubit is a basic unit of information. Unlike like 01, it's qubit, which is the basic unit of information. Okay. Similar to 01, but it has infinite state, as I mentioned earlier. Computer that uses qubits for processing of data and storing of information is called quantum computer. Okay, please remember this definition is important from quiz point of view as well. Next is the Memristor. Memristor is basically another innovation, a recent innovation which will replace transistors. So nowadays all the CPUs, or you can say your devices, are based on transistors. So one Memristor can replace 25 transistors. So 25 transistors can be replaced with one Memristor, and the size is very small. So if we start using Memristor, automatically what will happen, it will reduce the cost of the system, reduce the size as well. So Memristor, as name suggests, Memristor is basically memory with a resistor. So memory with resistors. So as you know, resistors are basically like to step down the current or the power to make the devices compatible with the power supply, with the main power line. Like for example, if you have iron, which may be let's say 1000 watt, but it requires let's say 20 volt maybe, but the one we are getting from our wall sockets, it's basically 110 volt. So we need to use some step down resistors which can step down this power. Memristors are basically the storage devices. So memristors store data by changing resistance based on the current passed through it. So basically this is Memristor. It got a resistor right here, and it stores the data based on the current which will pass through it. As I mentioned earlier, it can replace transistors, and of course it will bring a revolution in our electronic industry. Next is the holographic storage, which is mainly comparable with quantum computers, but holographic storage will actually replace, or it will entirely change the way how we store the data on secondary storage or on the memory, etc., etc. Holographic storage can, in our traditional way, let's say this is our hard drive. We store the data, read the data bit by bit. Okay, but in the holographic storage, what will happen? Data will not be in the form of bits, rather than the data will be in the form of lights, laser light. Okay, so if you just blink the laser light, it will transmit the light. I mean, the light can take multiple paths, and all these paths can simultaneously reach at a photoreceptive cell. Photoreceptive cell mean which receives, which can store these particular lights. So so you can, let's say this particular light might have one, this particular light might have 0 data, 1 0, and something like that. So all these particular data can be simultaneously written on this photoreceptive cell. So holographic storage can replace the existing 1010 or symmetric kind of writing and reading the data, and it can decrease the access time of over hard drives and the RAMs as well. Holographic storage mainly uses refracted laser light to store data on photoreceptive cells. So to store the data on photoreceptive cell and multiple data, as I mentioned earlier, it can be written simultaneously, and the best thing is it can store gigabytes in millimeter space. So very, very small space is required in order to store the data. Next is the artificial intelligence. We have seen a lot of applications of artificial intelligence around us. Artificial intelligence, AI, or artificial intelligence. And artificial intelligence is basically a branch of computer science. It's a branch of computer science that study how computers can behave and think like humans. Now, artificial intelligence can be of two types. There are two main branches. AI can be of two types. It can be natural language processing, and the second type of artificial intelligence is machine learning. Here, the natural language processing is basically where we study how computer understands the human language as it is spoken. So we are trying to actually work on those algorithms so computer can understand exactly the same words and execute the command. While machine learning is a field of study in which we allow computers or machines to learn without being explicitly programmed. So without being programmed, computer can learn with the past experiences or with the practices which you can say the designer can provide to computer and stuff like that. Next is the edge computing. And edge computing is basically it's something that is already in place just to increase the internet speed. So for example, let's say this is user. So user is right now, for example, located in Atlanta, and you want to access, for example, Facebook server. So mainly Facebook server is located in, for example, San Francisco. So you want to access this particular server which is located in San Francisco. So now what's going to happen? So for example, if you access this particular server from Atlanta to San Francisco, there's a lot of transportation delay. So in edge computing, what we do, we actually we place a server right in between. Rather than in San Francisco, it might be, let's say, in Austin, for example, in Texas. I'm just giving an example. Now what will happen? It will cut off this transportation delay, and now you can fetch the data from the closest location. So this is called edge computing, where we place intermediate servers in between the clients and the servers. So edge computing is basically where to increase internet transmission speed and you can say the decrease latency, which is basically delay. I'll explain it in a while. What is latency? Decrease latency, the intermediate servers are placed between users and cloud. Okay, and small portion of cloud services are also downloaded onto intermediate servers. So users can also can use those particular services. Latency, the word that we have used here, latency is basically a time it takes data to travel or to get to cloud, or you can say time it takes data to travel from devices to data center, or you can say cloud, and back to device, like a round trip time. For example, from here to here, this is called basically latency. Like if the distance will be less, automatically it will be less latency. If you have less latency, it means faster speed. The next is the ATAP, which is the advanced you can say technology and advanced project. This is basically a Google's initiative. It is called Google Advanced Technology and projects. So what Google is trying to do is, in this particular project, they're trying to make human hand as a universal input. This is basically what their plan is. So they envision a future where human hand will be the universal input device. And mainly they're trying to make a touchless interaction, like you just have to give, without touching anything, it can actually pull the data. Like it's kind of touchless interaction. There is a project called Project Soli. In Project Soli, the microchip is embedded onto device. Let's say you just have to put on the gloves, and there will be a chip inside the glove, and then you have to embed a chip on a mobile phone, and then you just have to shake your hand with of course in the gloves. If you shake your hand, automatically what will happen, you can control over the device or the cell phone. So in Project Soli, the microchip is embedded on, you can say, wearable, which is a glove, and cell phone or smartphone, to detect touchless interaction. So like it's a very simple thing. As of today, you just have to put on the gloves, which has an electronic chip, which will communicate with the chip which is embedded onto cell phone, and then it can detect the your gestures. It can like without touching anything, you can control over the device. Next is the brain computer interface. This is a project which is initiated by Facebook, and what they're trying to do is they are trying to actually detect you speaking silently in your head. Let's say a device will be put on your head. It will scan your brain. It will scan your brain 100 times per second and detect you thinking or whatever is running in your brain. They can visualize it. This is basically the ultimate plan. Other than that, the project is also they are also working on it. Like if you want to, they just want to make it like a touchless kind of a keyboard. Like you are thinking and it will start typing on your behalf. So in brain computer interface, what exactly the plan is, the goal is for the system to allow humans to type even faster than physical hands. So like you're thinking and it will type for you on your behalf. It also allows human or people to communicate with computers through thoughts. So you are thinking and you can send a message. A message will be transmitted from your brain to computer. Next is the what will happen. It uses optical scanning. Okay, optical scanning or optical imaging to scan your head, to scan your brain, which I told you guys 100 times per second, to detect you speaking silently in your head or in your head. So it could be actually a revolution in the investigations, like for example the lie detector and all those stuff will be replaced with that. Then we have a digital twin. Digital twin is basically like for example, this is a material. Let's say this is a tree. So we can make a digital twin, like we can make a software representation of this particular tree. Let's say this is a tree, or it could be any equipment. We can make a software which can behave like a tree. So we can do testing and we can do whatever we want to do with that software. Like for example, we want to see under this environment how this tree will, whether it will survive or not, and stuff like that. We can do that because we can actually make, we don't have to test it on the real particular equipment or a piece of soft system. It could be anything. It could be steel. If you want to actually study the behavior of steel material or any kind of material, we can make a software representation of that. So digital twin is basically a dynamic software representation of a piece of equipment or system that emulates the original material. It has all the same trait and everything. Other than that, the digital twin continuously learn and you can say generate possible solutions of issues from the physical counterpart. Other than that, what else it can do? So on the physical part, there are components, or you can say sensors. Mounted sensors, which are basically mounted onto tree or that particular physical counterpart. These components are connected wirelessly, of course, with cloud-based application. application, and it's basically the software, cloud-based application that receives and you can say process all data the sensor monitor. So basically, let's say this is the material. So this particular material will have a lot of sensors on it, and these sensors will continue send the data to cloud, and the application on which you are working on, it is basically also getting information from cloud. So let's say if you're stuck somewhere, if you want to make a digital twin of that, so this particular sensor will give information to cloud, and on the basis of this information we can make a software, we can see the runtime problem, runtime solution, and all that stuff. Next is the last few things. AOT is array of things, and this project is initiated by City of Chicago. And what this particular project is, so in this project what they have done is, let's say this is their downtown, so they have deployed 500 sensors, and they have mounted those sensors on traffic lights and some utility poles and all that stuff. What these sensors they do, these particular sensors, they detect air quality, traffic patterns, etc., and send this information. Like these sensors are deployed in the downtown of Chicago. These sensors, they are connected with the city administration server. They send the data on real time to city administrator server, and this server upload the information on the website. So citizens or the residents, what they can do is they can visit the website, they can see what's the air quality, what are the patterns and all that stuff. Some other cities, they are also trying to actually deploy these particular sensors on their in downtowns and all that stuff, just to have a common platform. Last is the 5G. 5G, it's already in place, as you know, in 2020, as many countries they have started deploying 5G, and US is also among them. 5G will bring a revolution in our communication, and especially in internet, because with the 5G the data rate is gonna be 20 Gbps, gigabits per second, and currently it is 18 Mbps. How they actually they can increase the data rate. So currently, just imagine, let's say this is the area, let's say a cell radio coverage area covered by this BTS. So let's say in 4G, cell radius is, for example, 3 to 10 kilometers or 3 to 10 miles, for example. For 3 to 10 miles, we just have one particular radius which transmit the powerful signal all around. But in 5G, what's going to happen? In 5G, let's say we have the same, let's say 3 to 10 miles area, but this area will be divided into more cells. Now for each particular cell, we will have a small antenna. So this small antenna will transmit weak signals, and now we can actually we will have to introduce more frequencies as compared to this. So now here we have limited number of frequencies there. For example, if we we can actually accommodate limited number of people. Now here, if we have more bandwidth, more frequencies, more users can be accommodated, and more data rate can be provided as well. So in the 5G, the most important thing to remember is it requires more antennas, with each antenna sending out weak signals. So please remember, it's a weak signal, because if we transmit strong signals, then of course your area will be bigger. So antennas are small, they will transmit weak signals, so we can have a smaller coverage area, because if anybody moves out from this area to other area, he or she will enter in another antenna range. So this is the best thing of the 5G, and that's the way how 5G has increased the data rate. So we will continue this lecture in the next class.